So what do I always have to look for first? Greatest common factor. What is my greatest common factor for number 1? 5. So I'm going to factor out the 5. When I factor out 5, I'm left with x squared plus 3x plus 2. Then at this point, if you're comfortable with the x method, that's what you'll be doing. What goes on the top? 2. What goes on the bottom? 3. What are my p and q? Yep, 2 and 1. So this factored out form is 5 on the outside times x plus 2 times x plus 1. Those quantities. Is that what you got? All right. What do we have to remember about number 2? There's a negative as a leading coefficient. Anytime there's a negative as a leading coefficient, I always want to factor out that negative and change the sign. Factor out the negative, and then just put the opposite sign. What are my 2? What's my p and q? Yeah, -4 and 2. So I have a negative, and then I have x minus 4 times x plus 2 for this answer. So any questions on this? Okay, here we go. We're going to start messing with problems like number 1, where you may not have a GCF and it becomes easy like this. So I'm going to talk to you about how we do that. Okay, so you're given a problem like this expression, 4x squared plus 13x plus 3. Remember, it's an expression because it doesn't have an equal sign. And the first thing you ask yourself is, well, can I factor out a GCF? And can you? No. There's nothing that you can factor out with a 4 and a 13 and a 3. This is what you do, okay? Because you have an a value, an a being that coefficient, that leading coefficient, because our general form is ax squared plus bx plus c. Because you have an a value that is not 1, what you want to do is you want to take this a and you want to multiply it by the c, okay? So that's where that AC part comes in here, on that little note that I made. So a times c. When I was first learning this, I don't know why my teacher told me this, but he's like, he called it the airplane method. I don't know why. He's like, oh, you're like on a little airplane. And I never forgot it. But AC, so 4 times 3. And what that does is it gives you a new product to work with in your x method. So now, what I'm going to do, instead of putting 3 here, what do you think I'm going to put? 12. I'm still going to put 13. Okay? So what are my p and q? 12 and 1. Now, it's not as simple as just saying x plus 12, x plus 1. Yeah? This is where that, I know it sounds weird, that bust the b part comes in. We're going to take this middle term and we're going to break it apart. Yeah? So, in other words, what you're going to do is you're going to rewrite this, 4x squared, and you're going to rewrite this middle term, this b term, as 12 and 1. 12 and 1 make 13, right? So, and it doesn't matter what order. So we'll just put plus 12x plus 1x, or just plus x plus 3. So what I did, again, I put AC plus the B for a reason, because you want an AC and then you want to break apart that b term in the middle. So I broke that b term in the middle to 12 and 1. Does that make sense? Okay. Now, what do we do with that? So go ahead and make sure you wrote that down, and then I'll tell you what we do. Yeah, in fact, we pull out a GCF. Okay? So I look at it this way. I'm going to look at these first two terms and keep them separate, and these last two terms and keep them separate, and pull out a GCF. Even if it's just one. One is okay here, and I want to write one. Most of the time we just say it's implied, but I actually want to write the one here. So in this case, what's the GCF between 4x squared and 12x?
4x.
So we have 4x, right? So that leaves me with what in the parentheses?
Squared.
X plus 3, yeah?
Squared.
Well, because 4x times x gets me 4x squared, yeah? Now, do you see what I'm doing so far? Is everybody with me so far? Okay, so what I did, again, AC busted B. So I took A times C, and I got a new product, yeah? That new product is now 12. I think of a P and Q that multiplies to be 12 and adds to be 13, just like we've been doing, yeah? And so now I need to rewrite this. These two are now going to be broken apart, because I know that 12 and 1 make that 13, right? So I'm essentially just rewriting this with two middle terms, yes? So instead of 13, I put 12 and 1, the 12 and the 1 that I got there. I'm just rewriting it. Then what I'm doing is I'm grouping them two at a time. The first two and the last two, yes? And then I will factor out what I can. I'll pull out that GCF. I'll leave a plus sign. Okay. Well, what's common between an x and a 3? A 1. So I'm going to factor out a 1, and then I have x plus 3. What's something that you notice about what's in parentheses? If it's not the same, you did it wrong. Okay? That's the key. If what you have in parentheses is not the same, then you did something wrong. It must always be the same. Okay? So, what does this mean for my answer? This means that I'm going to take the two outsides and I'm going to put them together, 4x plus 1. And then whatever's the same, I'm going to put that. That is my factor of 1. Yes. Where?
England.
Yes?
And 4 divided the factor of 4 plus 3.
No, well, you have to take 4. 4 times 1 is 4. 4 times 3 is 12.
Oh, wait. Okay.
All right. Do you kind of get this? We're going to do another one. But do you have any questions about this? It's just going to take some practice. All it is saying, again, it's just AC busted B. You take A times C, that's your new product. Then you break up the B term into 2. Then you factor out and you put it together. Yeah? You can always check it by FOILing, distributive property, you know. And if you get this, then you know you did it correctly. If you didn't, then you did it wrong. Okay, let's try another one. Okay, so you tell me what to do. What do I look for first? Yeah, but before that I look for a what? GCF. Is there a GCF? No. So now, A times C, 3 times 2. What goes on the top? Okay. What goes on the bottom?
No, it's
Negative 7. Yeah. Which reads this. See how far you get with that while I run and go. What P and Q did you get? Negative 6 and negative 1. At least we can get there so far. That's good. Alright. So I got the AC part. I have to bust the B. I have to break that apart into 2, right? So I'm going to rewrite this as 3x squared. It doesn't matter which order I put these in. I'm going to start with the negative 1 just because I'm going to go left to right. But you could start with the negative 6 if you wanted to. So minus x minus 6x, okay? Because I want them to give me this middle term in the end, yeah? And then plus 2. Does that make sense? Now we have to group them. That's why we call this factoring by grouping. We're going to group these 2 terms, and we're going to group these 2 terms. What is my GCF for the first one? 1x. Okay, you can just write x. Unless the only thing you can take out is literally a 1, then write 1. But in this case, I can take out an x. What am I left with? 3x. Okay, again, remember your exponent rules. We took a test on this. Whenever you multiply exponents, what do you do to them? Add them. So if you had an x squared, 2 plus 1 is 3. That's not this. That's x squared, right? That's a 2. So it has to just be an x by itself, because 1 and 1 make 2. Yes? Okay. So then this is what? Minus 1. And then I have the minus sign in the middle. What can I pull out here? A 2. Okay. And then I want to multiply. So I'm going to take out a 2. And then I have 3x minus 1. In the end, I want to get a negative 6, right? And I want to get a positive 2. And so these are the same, are they not? Do you understand that? Okay. So lastly, I put them together. Outsides and the same binomial. And let's check it. Let's just distribute. Do I get what I'm supposed to? X times 3x is 3x squared. X times negative 1 is negative x. Oops. Yeah. And then negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. I need to get this in the end, do I? 3x squared minus 7x plus 2. Yeah? You see, that's the point of that middle term breaking apart. We want to be able to get here. Yeah? Okay. Yes. Yeah, you may. Do the next one if you feel like you know what to do. I'm going to start this one on the board, and then we'll practice several, I think, after the next one. But it's the same process for all of them. Look for GCF. If you can't find a GCF, A times C, bust the B, so break apart the middle term, factor out. Yes.
So if you switch from like negative 1 to negative 6 and the factor x,
Yes.
we just get the same answer.
You will. You will. The outsides. You put the outsides together, and whatever's the same. That's the other factor. So whatever you factored out goes in one. Whatever's on the inside that's the same goes in the other. This one?
No.
This one. You factor out a GCF for these two, and you get x. You factor out a GCF for these two, and you get -2. Yeah? Because you want to be able to get this in the end.
In the parentheses. And 3x minus
Because x times 3x is 3x squared.
Yeah.
X times -1 is negative x. -2 times 3x is -6x. -2 times -1 is +2. Yeah? Okay. All right, let's take a look at this next one. I don't have a GCF. What's the first step after GCF? Multiply. Okay? Now what? Yep, where? What else? Yes. Now what? So, -7 and 2. Now what? Yeah, then what's the b part, right? So how will I rewrite this? 2x squared? So did you do plus 2x or did you do minus 7x first? Okay, plus 2x. Then what? Minus 7x. And then what? Yeah. Okay, somebody else. Now what? And the next step is factor. Factor what? First two. Okay. And last two. Okay. What do you factor out from the first two? 2x. Okay. What are you left with? X plus 1. What do you factor out for the next one? 7. What are you left with? X plus 1, right? -7 times 1 is -7. Yeah? Is that what you got? Now what? Not imagine. What do you do now? Okay, put them together. Which two do I put together? Yeah, 2x minus 7. And what else? X plus 1. Excellent. Did you feel like you got that? Okay. See if we get the same thing in the end. as you're finishing up, or when you finish, did you get this? And if you didn't, you know what you did wrong. Did you get it? Yes? No. Anyone? Yes?
I'm negative, so
You just leave it on the outside. You just leave it on the outside. Because what that will tell you to do is, when you do the distribution, at the end, make everything neat so that you get this. Does that make sense? Yeah, so you just leave it on the outside. You don't even worry about it. Just pull it out, just pretend it never happened. Which is a good life lesson sometimes.